A function is defined parametrically by x equals 3t squared and y equals t to the 6 minus 4t cubed. Find dy dx in terms of t. Given that dy dx equals 7 over 2, show that 2t to the 4 minus 4t minus 7 equals 0. Show that the equation 2t to the 4 minus 4t minus 7 equals 0 has a root alpha between 1 and 2. The recurrence relation given here with t0 equals 1.6 can be used to find alpha. Find and record the values t1, t2, t3, t4. Write down the value of t4, correct to 5 decimal places, and prove that this is the value of alpha, correct to 5 decimal places. So there's the question then. Let's have a look at it. I'm going to do this one here. So let's copy this. I'm just going to copy this. Oops. Try and copy this rather. And pull it down. So we're going to find dy dx first, aren't we? So let's do that. Okay, so here's the problem then. So we need dx dt. Just differentiate simple powers with respect to t. The 2 comes down, 2 3s are 6, t to the 1. Dy dt then. 6 power rule, 6 comes down, t to the 1 less, 5. 3 comes down to be with the 4. 12t 1 less is 2. So dy dx then. Okay, so it's dy dt over dx dt. Here we've got 6, this top thing has a 6t common, doesn't it? So let's pull that outside a bracket straight away. And inside we're going to have a t to the 4 minus 2t here to give the minus 12t squared. That's dy dt divided by dx dt, which is 6t. So we can see these cancel, and that tells us then dy dx equals t to the 4 minus 2t. This is part 1. Part 2. Here dy dx equals a value, doesn't it? Let's have a look at it. 7 over 2. So this equals 7 over 2. So that implies then move the 2 up to times on the other side. So it's 2 of these minus 2 of these will equal to 7, and then move the 7 across. 2t to the 4 minus 4t minus 7 equals 0. So that's that verified. Now part B, we need to look at this equation and verify there's a root between 1 and 2, don't we? So f of t, let's give it a label, minus 4t minus 7. Now f of 1 and f of 2 is what we need to look at to see if they change sign. And if they do change sign, there will be a root between 1 and 2. So put 1 in, 2, 1 to the power is just 1, minus 4 times 1 is minus 4, minus 7 is minus 9. Put 2 in, 2 to the 4, 16, 32, 32, 4 2s are 8, minus the 7, 32 minus 15 is 17. So yes, a root lies in between 1 and 2. So we've verified that, haven't we, because it changes sign. Now we turn our attention to the recurrence relation. Let's just grab this recurrence formula then, and we'll move that down. T0 is 1.6 and we want T4. So here it is. So this is the next part of the problem, which I think is part B actually. Yeah, there we are. Okay, still doing part B. T0 is 1.6, so let's put it over here. T0 equals 1.6. So T1, T2, T3, and T4 is what we need. So let's type them into a calculator then. So first of all, the 1.6 needs to go in memory. So just, oops, cancel. 1.6 equals, and it's in as an answer, isn't it now? Good. And now we need to just type in this equation here. So 4 time bracket, and then another bracket for the top of the fraction. 4 times answer plus 7, close the top bracket, divide by 2, close the whole bracket, power 1 divided by 4 equals. So the first is 1.608861. 1.608861. Let's keep it in the calculator. We've pressed equals, so it goes back in the answer, and press equals again. 609924. 1.609924. Next one. 610051. 1 point. And then the T4, which is what we're interested in. So press equals once more. 610067. 1 point. So T4 then to 5 dp, which is what the question asked us for. Let's just double check that. That it said 5 dp, yeah. Prove this is alpha to 5 dp. Okay, so it's 1.61, 1, 2, 3, 4, 5. So the 7 rounds to 6 up. 0 to a 7, and that's to 5 decimal places. Now we need to look at f, either side of this value. We need to look at 1.610075, and we need to look at the function at 1.610065. If they change sign, it means there's a root that lies in between these values. In a sense, if it lies between these values, it will equal this value to 5 decimal places, won't it? So we need to type the equation in then, 2 times 1.610075 to the power 4 minus 4 times 1.6175 minus 7. Positive, small positive, 0.0001, isn't it? 0.0001. Whereas if we put 65 in the calculator, then let's just toggle back and put a 65 in instead of a 75 for the number in these two places, we should get an opposite sign. And we get minus 0.0001. So alpha is equal to 1.610075 decimal places.